Dallinger grew out of our attempts to scale up the transmission chain design. Transmission chains are a technique that go back to Frederick Bartlett in the early 1900s, who created experiments on human memory where he would bring somebody into his house, give them a story. In this case, they were British participants, and it was a Native American folktale. Ask them to read through the story, he would take it away, give them a blank piece of paper, and ask them to write down the story verbatim. He then send them away, bring in a new person, and then now, critically, rather than showing them the original story, he showed them the recollection of the first participant. By doing this over and over again, you get a transmission chain, and you can study how, for example, cultural effects change memories as they're passed from person to person. We wanted to run many studies like that and also to scale up those designs to more complex network structures, more complex processes played out over different kinds of networks. And so we built Dallinger. Dallinger is an online platform, and its focus, and I think what it's the clearest point of distinction from other online software platforms is that what it's good at is conditional recruitment and having logic that allows you to pass information from one person to the next and to change the structure and content of one participant's task based upon what previous participants or other simultaneously present participants have done or are doing. So for example, in a transmission chain, with Dallinger, the system on your behalf recruits a participant from a crowdsourcing platform like Mechanical Turk. It then runs them through the experiment. When they're done with the experiment, without the experimenter intervention, it runs some data checks to check data quality. If it fails that, it goes and recruits somebody in their place. And if it passes it, it recruits a new person to the end of the chain. And in doing that, you're able to run many more chains than you would if you were doing this in the lab or needing person-by-person intervention. To show you how this is true, I'll just briefly describe the structure of the biggest experiment we've ever run on Dallinger, this biggest single experiment. That experiment has a structure that's pretty similar to the Wright-Fisher process of population genetics. And in that study, our system, without experimenter intervention, recruits a batch of 40 participants who run and do some individual psychology tasks. They're sent away, and then a new batch of 40 participants is automatically recruited and and the structure of their task depends on one participant selected at random from the previous generation. Send them away, it automatically brings in a new generation of 40 participants, and it runs this forward for 60 generations. What you end up with is a complex network structure with thousands of participants where end-to-end the experiment, if everything goes well, has run without our intervention. What that means is you can now run tens of these and have that entire network, that entire transmission chain, the entire simulation of people be the unit of your experiment. That can be a single data point. Okay, so that's the goal of it. It's not meant to be the kind of thing that you can learn end to end in an hour. It's meant to be a tool that you can get started with quickly, doing simple designs that are already built into our demos. Like if you want to run a transmission chain, you can get started running that right away. But typically people have more complex needs and they want to try out new kinds of network structures, new kinds of processes playing out over those. And our method there is to allow you to define the network structure and the process. You do that with these functions. For example, create network. There's some built-in networks. You can write your own if you want to. And there's some built-in processes that define what happens when a new node gets added to a network and what happens when somebody makes a decision in a task. We've been working hard to try to scale up recruitment, and so though the platform is primarily connected to Mechanical Turk, we've been working to create a network of different recruitment services so that you can use Dallinger, you can recruit participants from many different sources. It is true that you can also, if you want, you can bring your own participants so that you can, if you already have some recruitment service like your own lab web page that gets a lot of traffic, you could send those participants to the site. Though you won't necessarily have the tight integration of the timing of the recruitment that you would get if you were using existing crowdsourcing service. Okay, thanks. During the demo, during the tutorial, I'll walk through several different experiments that we've run and show what it looks like from the perspective of a participant to run an experiment using the system end to end.